Що таке дистанційне
So
зондування
what
землі?
is remote sensing of the Earth from Spain? What kind of advantages do people get here on Earth from this technology? I'm Maria, an assistant of American House in Kiev, and we have here today Sергієм Янчевським, the head of the Information and Analytical Center of the Ukrainian National Center for Space Management and Testing. And he will give us more information about this technology. If you are space fans, just like we are here, and space exploration, remote sensing is something that's interesting, get tuned. We are doing now a Tech Space Hackathon, Europe Online Hackathon with Garage 48, Space On, and the US Embassy in Ukraine. In case you have questions during the presentation or after it, you can leave them under the stream, and I will certainly pass them on to Sergey. Sergey, hi, thank you for coming here today. Let's start. Thank you for inviting me. The topic actually is very interesting. It's probably not as large as the space itself, but I tried to prepare an interesting presentation for you today, and I think there are things that we can talk about. Okay, then shall we move on to the presentation itself? I'd like to tell you not only about the remote sensing of the Earth from the space per se, but also talk about the global tendencies that we find today on the market. Honestly, these tendencies, out of which I identified 7, are very impressive and inspiring and pushing us to start new businesses or work more, settle some new directions for research. I will talk about such things to such respected audience because I'm here to represent National Center, Information and Analytical Center of Ukrainian National Center for Space and Management of Testing. And we are the only institution in Eastern Europe who has such kind of a structure which manages satellites, receives special data, processes data, control navigation field, geophysical field, and monitors the space situation. You can see the scope of our station on the slide. Basically, it's from Spain to the Ural Mountains, from Scandinavia to the Near East. This is the range. And when the satellite flies over, it sends information to our station. We can get the data online, process it quickly, and then see certain events like fires, like some kind of disasters, follow the crops, forests, and so on. If we are talking about global tendencies of the space market, well, the idea usually here is that the big things are best viewed at a distance. We should go back to the times when it all started. In remote sensing, the shape of it that we see today started back then. If we start looking back at 1990s, only 15 countries had space research and had remote sensing and invested $23 billion, a huge amount of money because the value was very different of that dollar. And just several years after, we see 58 countries from all over the world who do their best to implement their own space programs and have their own satellites. They invest $42 million into that. More countries, more money, more taxes, more expenses. Just several years, 5 years after, we see these are 80 countries, $70.8 billion. And you can find Ukraine here, 28 million a year that was used to implement one of its first space programs. Generally, as of 2021, about 84% $4 billion are invested into space programs, and more than 120 NGO governmental agencies are active in the field. That tendency demonstrates that space is interesting and important. If we try and analyze the global space market, we'll see 5 primary segments there. It's reproduction of satellites and rockets. There's launches, services, then Earth stations, operators for space systems, and services. Ukraine, in each of the sectors or segments, has something to say. We haven't lost our potential, we're trying to improve it. And as of 2020, about 385 billion American dollars. This is the amounts of money of which Ukraine should have its share, I believe. And we have all the capacity for that. You see that state space agency is active in all of the 5 segments, and the national center that I represent here covers the 3 segments on the slide. Most money is made at the level of services. That's the segment where space activity results are turned into specific programs or services that can help you make your decisions in management or territorial management and so on. As the forecasts say, in 2026, 2028, the profits will grow to $500 billion. So there is much we can do. Segments of the remote sensing market. Here you see 5 primary directions too. First of all, it's creation and launch of space vehicles for remote sensing. Then it's operation. Our organization is responsible for operations. Produce and launch a satellite today takes about 2 years, but operations can last much longer. Landsat 7, for example, is still active for 26 years. Landsat 5 is also there. These are American satellites. And every year, every day, they need to be managed and operated. And we need to make sure that the satellite gives us useful information, and that's what we're doing. The third direction is receiving and then distributing data, processing data, and turning it into a value-added service. The idea here is that people who are absolutely not related to space and whatsoever can use the data, use it for decision-making. And the whole world understands that it's an important problem, the big data. So it's big data is important for remote sensing as well. So big data analytics is another direction. Again, a lot of money here. Very briefly about the first tendency. What that means is this. Well, each of the satellites used to cost a lot. American military satellite, Ihula 11, the historical satellite, was huge. It weighs about 8 tons. And just launching it to the orbit cost a lot. Then refueling, then operation of such satellites. That was really a lot of money. What do we see now? And generally, we need to understand the number of such satellites was limited. And who could use information from there? Some classified scientists or military personnel, nobody else had access. So what's now? Today, the situation is very different because everything became smaller. Now it's a CubeSat, which is a kilogram of weight, or about 3. So they're small. But such satellites give you information about what happens on the Earth. More than 2,000 satellites exist now. They are all operational. About 500 out of them are used for remote sensing of the Earth and military surveillance. The scope of using became larger. Anybody now can order from a distributor data from a satellite and use it. And the question number 3 is what will happen? Up to 2028, we expect that more than 12,000 of such space vehicles will be launched, meaning that it will be a larger number of remote sensing satellites too. We've just recently had a report from Sky Research, and according to their data, the new startups, including, they can expect that in 2030, orbital constellations will be made of 25,000 satellites. So there will be huge amounts of data. And then what's going to happen to it next? This is a bar chart that illustrates the tendency. You see that starting in 2010 and then forecast into 2028, the number of satellites will be increasing. And these are satellites that weigh more than 50 kilograms. But there are also vehicles that are larger than CubeSats, and there are thousands and thousands of them as well. So these will be radar, optical, parametrical satellites for remote sensing. So we can expect that in the nearest future, we shall see anything that's happening on our planet. I'm sorry for interrupting you, but I have a question. Who needs them more, the satellites? Businesses, governments? I'll talk about that later, but generally, mostly these are the military who need them. Of course, you understand there are certain tensions in the world, and they, the military, need to be ready for anything. And satellite imagery is one of the most legal ways to do recon. There are no prohibitions for that, unlike some other methods for data collection. So yeah, of course, this will be the military. Tectonic moves and shifts are really happening in what's happening in the value-added services that we mentioned, because nobody imagined that so much value and money could be there. Okay. If you have questions to Sergey, please write them underneath the stream and we will transfer them to our speaker. So, can I continue? Another bar chart that's interesting. This bar chart shows a different tendency, the improved role of private space exploration. What's interesting here, if you remember one of the first decisions of Barack Obama, he made decrees that allowed businesses to do state contracts in the space industry. So starting with 1957 and first satellite launches, all of the activity around the space was done by governments and in the interests of governments, for the military, for the civilians, but that was government business. Starting in 1999 or 2000, new things are happening. The state or governments are stepping back and businesses are coming forward. These technologies are already at the level when a small company, which is an example for me, an American company, several people created this American dream, and now they are the only team in the world that can film the whole of the planet once every day, almost unreal. Or a Finnish small company, ISI, 4 students from a university, a very small place, but they got together and they have an orbital constellation that works on the orbit perfectly. They did it all from the scratch. They use their radars, so their space vehicles are flying over, and they're considered to be one of the most effective startups. They are increasing their activity, there is investment, the government sees that it's good business, they will give them money as well. Okay, the tendency is this: the private space exploration is increasing in the remote sensing as well. Here, this is a slide from Euroconsult. You can see here a large number of startups, larger or smaller, starting basically as a garage. So from a small lab, from a garage, or a student's idea, Planet can start, or Black Sky can start, or Satellogic. Satellogic, for example, was sold several months ago for $1.1 billion. And this is a company which was initiated by several students who wanted their own orbital constellation. Such startups exist not only in the United States, you can find them in Asia or in Europe. And I really think that in Ukraine we will see such startups because we have a lot of talented young people, well-educated, who know about space exploration. So here you see startups generally in the world. The larger number of companies who do remote sensing are in the United States. About 5,000 of them are American. And on the whole, 10,000 companies are generally in this area. This market is increasing, and Ukraine really must get its share, and Ukraine has everything it needs for that. There are many things where we are the first in Eastern Europe, and we need to use this potential. The next tendency is technology of remote sensing. Like I said, it used to be something for the scientists and for the military to use such data. Now it can be used by everyone. We work with regional administrations, with ministries, different government agencies. We help management because any management decision, if it's right, it's based on space because it's related to a map or to some coordinates. They always mark that you have to start here and finish there, or the house has to be located in this place. So it's all related to spatial technology and very closely related to remote sensing and navigation. Of course, this means new working places. This is very close to IT because people who process data, they need to know very well certain things in mathematics, software, and space is really the front line. Whatever is new in science is used here. Human development, human potential development, I mentioned. Agriculture is impossible with space technology. In Ukraine, we created systems who can measure of the fields where and calculates where the seeds go into the ground with the resolution of 2 centimeters, because you know where your seeds go, where your fertilizers go, you don't waste anything. Rational use of resources, that's clear. You can see just everything that's happening. Development of the economy of the state and the society, that's obvious as well. We understood it long ago in Ukraine. This is the research that we did with executive agencies in 2016 and 17. We asked our governmental agencies, the civil servants, whether they needed data from satellites. And what we realized was that we received more than 300 million worth of requests for imagery. People even from faraway places, some regional administration wrote to us. They told us they were ready to use this imagery. So you see, our nation is really very well educated. Here, I want to show you the plans. According to the decision of the president and our leadership, SPACETECH EUROPE must be launched this year. By the end of December, we are getting ready. And then at least 6 more satellites of high resolution, which will show us smallest things. 50 by 50 centimeters in a pixel. Well, these are the plans, we shall see. These are the examples of the data that we will get from SPACETECH 2.1. Some people may say that 7.8 meters for a pixel is too large. Actually, a lot of things related to environment, to natural disasters, agriculture, using that type of information. And we also have that type of data. This is the port of Odessa seen from the space. We just made the picture when the weed, that the algae were really booming in the sea, so it looks green due to that. But that's beautiful from the space. Another tendency is that space data is used for the military needs. Nobody expected here that it will be the business decisions from remote sensing. Well, that will become so strong, so modern, so high quality, that the military, who need everything that is best and they need it now, will spend money on that. And this is real business. Space systems are used at peaceful times, during conflicts. This used to be strategic systems, but now you can find them at tactical and operational levels as well. That's an interesting tendency, but it was unexpected. Current situation at the global market of remote sensing of the Earth. We used to believe that it would be really cool if a country had one remote sensor, one communication satellite, and that was all. Right now, business decisions need orbital constellations from 10 to 170 satellites at the same time, and we have a large number of such constellations. According to experts, in 2030, we will get to the figure of 25,000, and now we have 2,500 of satellites. This is the investment not only comes from the governments. $9.8 billion were the governmental investments into remote sensing of the Earth. But venture funds invest a lot. I'll talk more about it later. That was unexpected too, and this growth is also very rapid. The yearly growth will get to 12% very soon. Just to give you an example of Chinese economy that grows 9% a year at this best times, and here we find 12%. Service market, data market for 2020, it's about $4 billion. And this is just the raw data. Process data that is provided to the customers. Here, the total market is larger. Of course, the primary users are the military from the US and other countries. They buy the most data from satellites and they want detailed images of certain territories, which means that the resolution is better than 1 meter. It's all clear with the military, but another direction, which is very important for us, for people, is agriculture. The number of people is growing. We see global climate changes. Remote sensing of the Earth is very important here. So we can use it for precise agriculture. We can see here on the diagram how it is all connected. We can't do it without distance remote probing, without all of the space methods, without satellites, without processing data, using methods that give us an opportunity to see what's happening in agriculture, covering huge territories. You can imagine the fields we have in Ukraine. So what we see here in Ukraine is this. You probably know that last month land reform started, and we see now there is a problem with cadastre map. We use different pictures and we see that what's fixed in documents does not meet the real life situation, and that's a challenge. For that, we have a special technology that creates images from a satellite lapped over a picture, and then we will match heights or altitudes. And that gives a possibility for precise measurements. 2 months ago, we signed a special agreement between the Space Agency and the State Cadastre Agency, and we're trying to resolve the problem. This is agricultural monitoring at the level of the country. Ukraine is the largest country in Europe, comparable to Spain. And all of this large territory, we monitor 2 times once every 2 weeks, and we can see how the fields look. The resolution here is 10 meters. You see what's happening, something's dried out, something's been watered or not, and you can have an understanding about the crop you can expect. This is regional monitoring with more detail. Of course, this is more complicated, but it gives you an opportunity to see what is planted, what kind of crops, their total area, and this is a field. It is uneven due to several reasons, and as far as I know, in countries with advanced agriculture, they would just use a drone that will put additional seeds into the areas where it is necessary. Again, this is precise agriculture, which helps you save money. Climate change, less water, and from the space, we can see very well the territories that get enough moisture, which need enough additional water. And generally, monitoring and management of water resources without remote sensing is impossible. It's a geoportal that we have. It exists for many countries, but Ukraine is a country that really absorbs new tendencies. And now we can see that basically each of the regions has its own geological portal. And you can get data of various kinds from here. Any of our citizens can log in and see what's happening, floods or temperatures of the soil, snow, anything. And to finish with this fifth tendency related to agriculture, I just wanted to show how relevant remote sensing is for Ukraine and for the world. If we look at 2019, then just from selling grains, the country received $7.7 billion. In general, agrarians spend $500 per hectare. What they need to improve is just $5 per hectare, and then they will get better crops. In case of Ukraine, it's more than $2.5 billion, and that's the amount of money that our gas and transport system is worth. The next tendency is the role of radar space vehicles or satellites. Radars are a separate thing. So this is data that is received not just as a picture, but a radar signal is emitted, then it's reflected from the Earth, received at the sensor, and a picture is made. It's all black and white. Optical systems can only see during daytime, and if there are no clouds. If there are clouds, you can't see anything. For the military, it's important to see what's happening at night. For people in agriculture, it's important to see what's happening under the clouds. Are the crops growing or not? And that map shows you that according to NASA data, optical satellites can only be used to monitor Sahara, Sinai Peninsula, Arabian Peninsula, and a bit of Africa, and that's it. Everything else gets clouds, and the radar can film during the day, during night. It can get information during rain, snow, or anything. So it's a unique opportunity. Radars were not so very well developed before because technically they're complicated. The images are very expensive. One image could cost up to $10,000. So, and the people who could process such data, there were few too. Maybe 5 or 10 people in Ukraine could do it. Very often people couldn't even open this image and see it. But with Sentinel satellites, European satellites that provided access for free to radar data, they became very quickly well developed. So these are the examples that I can show you. Let's imagine it's kind of a military object. There is something, but it is covered with clouds. So do we find military equipment there or weaponry? We don't know. But a radar image demonstrates these red dots. Something is there, the equipment, and we can understand the size of it. The resolution is 10 meters, so it's kind of like dots. We worked with various companies, American companies as well, and you can see how well developed these images are now. You can see what kind of equipment this is. In the top right corner, this is data from Sentinel, and below it, it's already 50 centimeters per pixel. So compared to optical data, radars are very close. This is our place, a part of Kiev called Pechersk. Optical image, and this is a radar image, 50 centimeters of resolution. It's the same, but you can see a lot. And if we have enough specialists, we can understand it all. So, speaking of specialists, where are they trained? Do we train them in Ukraine? Yes, we do train them in Ukraine, but not specifically for radars. I think these are amateurs, more or less, who do it. But anyway, people who are really specialists, they learn a lot in Zhytomyr, in Kharkiv, in Kiev. You can be trained to analyze optical data. We work with different countries, and we can say that our specialists are good. Canadian specialists came several years ago, and when they saw what we learned to do with radar data, they were impressed. And Canadians are one of the best in the world in terms of working the radar imagery. Yeah, so it's good to know that we are good. So for radars, the numbers increase from 18 to 25% of the market will be covered by radars, and they will help us with blind spots that we couldn't deal with some time ago. And I'll mention startups again. Here you can see the progress over the 5 years that have passed. Small startups are planning to launch 240 radar satellites. There used to be 4 or 6 of them. They want 240. And they want to plan repeat flyover with the time lag of 10 minutes, which means that they will be able to see one and the same spot every 10 minutes. So this is 24/7 monitoring. And the resolution here is 2550 centimeters, which means that you can see a car. This is a lot of information, and these are new opportunities for development. Now, we will talk about big data. There are many satellites. Compared to previous generations, they can provide us more data. Each image is now more intense in terms of information, has more layers. It has several spectral bands, like a cake, many layers. Each layer has a certain type of information, and the combination of these bands gives you additional information about your vegetation, about moisture, about temperatures of the surface. So there's a lot of opportunity in that. And what I promised to mention is this. There are new players on the market, and generally new players are coming. You can see the diagram of what it used to be. Mostly these were military companies, sea monitoring, maritime businesses, several years, and we see 44% growth a year in the financial sector, meaning that banks, insurance, credit institutions, they all understand now how important this is and use data. They can give loans depending on crops, for example, and they use information from space. And again, they can have an opportunity to see how well the money is used. I was once told a story. It's a country in Europe, and they allocated a lot of money for their agriculture and then checked the industry with simple data in panchromatic band. Some of the farmers bought from China plastic trees, put them in the field, and used that as a demonstration of their activity, and then just said that, well, we didn't get any kind of crop to harvest. But then when multispectral sensors were used, of course, the truth came out. And I will give you some examples then again. But back to big data. American military, they're really cool. I will talk about them again here. Geointelligence is a wonderful conference which is all about remote sensing. 2011, a lot of time ago. But even then, American Army was overwhelmed by the amount of data they received from remote sensing as compared to 2006. 53 terabytes a day. They didn't know what to do with it. 2017, chef of National Geospatial Agency said that to process all the data that we receive from remote sensing, we need 8 billion analytical staff in addition, which is basically all of the people that live on the earth would sit down and do processing. A lot of money is invested into the segment. Google and Amazon also invest to work with big data. One image of Sentinel can be from 2 or 3 gigabytes to 12 pre-processed, and you can get a large number of such images. In Ukraine, in our national center, we have the 6th hub of Copernicus system. So information from 6 European sentinels are streamed to us, and Europeans tell us, so do you want to get everything that we film from the territory of Ukraine, about 2 terabytes a day? This can't be processed manually. Decipher it in an old way is absolutely impossible. So these are advanced mathematics or artificial intelligence, machine learning. These are all new approaches that are used now. That's an example of such new approaches. Maritime monitoring. And here we're coming back to radars. We used information for 2 years, 2016, 2017, processed it over a short period of time, and we received more than 305,000 of surface objects. You can see that on the slide. So, based on this data, you see the directions, the tensions within them. The upper map shows the size of ships that follow this navigation routes. If you look at the Crimea 2016, 2017, you will see that there are no direct accesses to it. It's just near the coast navigation, and whoever comes closer breaks the law. So hurricanes, coming back to credits and banks and insurers. 2017, a hurricane in 3 areas of Cherkasska and Poltavska regions. Everything was ruined. When local authorities went there in their old cars to see what was happening there, but our specialists needed 4 hours to analyze this information, 30,000 hectares of land, and give this information to the Ministry of Agriculture, to regional administrations. People were shocked because for each field, they could see what it was before the hurricane and what it is now after the hurricane. Some of the farmers came and say, well, I lost everything, please pay the insurance. But the data from the satellites demonstrated the real situations because sometimes people were trying to cheat. These are April fires along the border with Belarus. Satellite data gives us a possibility to see some remote areas, what's happening there. I don't think these are natural fires. We can understand that these are arson. This little spot demonstrates more than 40 spots of fire. And they are placed in such a way that the smoke goes to Kiev, and then from Kiev to Zaporizhzhia and Dnipro. And some of the formaldehyde reached Novosibirsk in Russia. So you can see the scale of the fire. This is monitoring of seaports, port infrastructure. This is the Prut River. When it flooded, the president went to see how things were happening, trying to help the people with radar data. We had the image of the river before the flood and during the flood. We overlapped the territories with a high-resolution image where we can see individual houses, and we could immediately see who needed help, which fields suffered, which houses suffered, and we could calculate the expenses. It would have been impossible without such technology now. So the tendencies are all summarized here, and we are ready for discussion. Thank you for the presentation. We have some questions from our viewers, and I remind you once again that if you have questions, please go on. We were just giving examples of how this data is used. Anna Khmurova is asking, in which the way does the analytical center is now working with private businesses, state institutions, or provide services to common people? Oh, well, to the services that we provide to the citizens were in my presentation. GeoPortal is something that you can use. You saw the web address in the presentation. You can go and get the data. Government agencies. So these are regional administrations. These are ministries. We provide them information for free. This satellite imagery on their request. So they send us a request, they send us coordinates. There is a certain period of time needed for people to get used to it all, but we see a lot of activity. There are many requests that we receive. Finally, our civil servants realize that they need it, and it's a good source of information. Thank you for the answer. Stanislav Krylov is asking, do we need to develop our own satellite connection, or will Starlink suffice? It's a philosophical question. So if you believe you can, you have ideas that can be better than Starlink, then it's worth doing it. I remember the first presentations when a planet came to us and explained the idea. They had large fleets of satellites, 150, 170 satellites that would make pictures of the Earth every day. Everyone thought they were crazy. That was impossible. But when they did it, when they probably became the first unicorn company and they received $1 billion of investment and started using it, it became an example that nothing is impossible. It's the new world. You have to believe in yourself. So if you feel you can, why don't we? Of course, it's probably worth looking at what Starlink does, how that goes for them. What they tell, they promise it will be very interesting, but we will live to see what it will happen. In case of planet, when you have a satellite which weighs 4.5 kilograms, it is a small thing. Well, a sun battery, but still it's a small one. And this size of a satellite can make you images to the power of 3 centimeters. This is amazing that a person can do something like that. We have some 5-10 minutes to get your questions. I have a question so far. Maybe it's a naive question, but anyway, can I order an image from a satellite? Can private persons do that? Yes, they can. When we work with state agencies, it's a little bit unregulated so far. We've been trying to lobby a law about remote sensing of the Earth. I'm one of the authors, but it's not moving anywhere so far. We buy resources for the state. We receive information, we send it to the government. Selling it to private individuals, well, it has to be regulated in some way. It's just a different kind of business. But so far, there is a large number of private companies that will sell you a piece of data like that. And well, I will not do advertising, but you can find them in Ukraine as well. You place an order, you get your image. Not many people in the country can open such image and will know what needs to be done with it. You need to know how to work it. You need to have special software. You need to be trained to use it. Okay, thank you. That's interesting. I had one more question. We talked a lot about how satellites and satellite imagery are used for the economy, for agriculture. So what are the tendencies for future in terms of ecology, environmental impact? We researched this issue. There was an interesting book that was published by University of Irkutsk with a powerful team of scientists at the time, and they explain that satellite data can be used for more than 318 tasks set with ecology. These are situations with the forests. These are various other things related to environment. I think actually it can be a larger number than 318. Now satellites are more improved. They have better opportunities now. We don't have questions from the audience. So if you do have something, please write your question. Was it a boring presentation or not? Just people are reflecting. Probably one more question that I have is how do you see the future of Ukraine in space research, space exploration, launch of new satellites. Ukraine has a huge potential and a lot of talented, well-educated people. The past, starting with Korolev, who was born in Zhytomyr and educated in Kyiv, in Odessa, and many others who are prominent specialists in the sphere. We have it all to develop in this direction. Out of all of the Eastern European countries, we are the only one who have land segment. We have the experience of producing our own satellites. We have this experience with Brazil, which will probably not very successful. We have missile systems, Zenit systems. So Ukraine has really huge potential. And in my opinion, we probably need some political will, political decision. Ukraine is a space state, but more specifically, this is what we're doing for it. And these are the deadlines for it. And then this mechanism starts rolling on. There is movement and something big starts. South Korea started basically from the scratch, but their results are very impressive. Ukraine will manage, Ukraine will do it. So thank you very much, and we wish success to Ukraine, to our scientists, researchers who work in this direction. And we have a question from Lucy. So the number of satellites that are monitoring the Earth, what does it mean for privacy? Just usual people. Well, privacy will be there because the resolution that we have now, 50 by 50 centimeters, just several systems can do 30 by 30 centimeters. That's not what you see in the movies. An image from the space and it can give you somebody's face. It's impossible. You will see a shade, which is slightly larger. And from that shadow, you can understand that it's a person. So space systems will not mess with privacy. But if we can imagine that science develops well enough to do it, well, there are certain limits of the atmosphere, of its permeability. And launching such a cool satellite, like I told you about Kihola, that weighs 8 tons, this is very expensive and it's unreasonable. Thank you very much. Thank you for the answers. Thank you to the audience for being with us and asking questions. We have some interesting comments. Stanislav Kirillov writes that the presentation was not boring, it was very intense. Igor wrote, the material was very interesting. And our viewers are grateful for such an interesting topic and the discussion of tendencies. Thank you for being with us today and sharing your view and explaining remote sensing to us. So maybe you still have something that you want to tell to our audience. Do engage in science. Go for new things. Nobody will know the genius in you and the field where you will be successful. So maybe you can do then something that nobody else could. And remote sensing or this space exploration can be one of the segments where you will be the best. Go ahead, get excited, go forward, use this data. You can find a lot of it for free, a lot of free software. So be creative, aim high. and just this people from the Aalto University, or people who, boys and girls who created Planet. This is inspiring their experience. Everything's doable. Just set goals and go for it. And I wish you great health in such difficult times. So please have your goals and go for them. Thank you for being with us and see you later.